my name is Keshwani. That's Keshwani, Keshwani. We are here because we want to prepare for the GMAT. We have been solving GMAT math problems out of this book here, GMAT Review, the official guide, the 13th edition. If you do not own this book already, purchase one immediately. You're going to need it. This book contains 230 problem-solving questions. It has 174 data sufficiency questions. We have already solved every single one of these problems. If you're interested in watching the original solutions to these problems, you will find the original solutions from day number 1 through 250. Right now, we are in the middle of redoing the problems, and we are on page number 280. Please turn to it. Page number 280, and we are on problem number 60. We have 3 more problems to go on this page. Number 60. Number 60 says, what's the value of n in the following equation? Negative 25 plus 19 plus n equals s, we are told. It's a very silly question. I realize that. I'm fully cognizant of it. But it's there, so we have to do it. Let's simplify this thing. That gives us n minus 6 equals s. The first statement, if you look at it, it tells us that s equals 2. Well, what the hell? If s equals 2, we can figure out the n. The question is, how's the value of n? S equals 2, we can figure out the n. N is s plus 6 is just 8. A, D, B, C, E. The last bit that I did there just now, the last 2 seconds that we just wasted, was not necessary. We don't actually have to do it out. It's quite obvious that it is doable. We can do it. We can figure out the value of n once we know the value of s. N equals s plus 6. Because we just established that the first statement by itself is sufficient, we know now answer cannot be B, C, or E. It would have to be either A or D. Let's look at second statement. Because the first statement was quite sufficient. The second statement tells us that n over s equals 4. Well, here's our one equation. Here's our other equations. We have 2 independent equations. We have 2 independent equations and we have 2 unknown. Of course, we can solve for the 2 unknowns. The second statement by itself is also quite sufficient. The answer to this question is D. In the real exam, we do not have to waste our time to actually solve for these variables. You understand? We're going to do it here just for learning purposes. What we're about to do actually is a sheer waste of time. This is not something that we'll do in the real exam. Let's do it very quickly. N over s equals 4, which is same as saying that n equals 4 times s. N equals 4 times s. We can put it in here. N equals 4 times s, so it's 4s plus s plus 6. 3s equals 6. S equals 2. And if s equals 2, then n equals 8, as we found a little while ago before. They never contradict each other. And the first time we found out that s was equal to 2, and this is exactly what we find here. Let's do the next one, shall we? Number 61. Number 61. This one was quite straightforward. I know, they go from sublime to the ridiculous. Number 61. In number 61, we are told that everybody, we are told, got either 1 scoop or 2 scoops. Everybody got either 1 scoop or 2 scoop. In other words, they're telling us that there was nobody there who did not get ice cream. Everybody got ice cream. Some got 1 scoop, some got 2 scoops. So far, so good. The question is, how many people were there? How many people were at the party where they were served ice cream? Every one of them was served ice cream. Some decided to have 1 scoop, some decided to have 2 scoops. 2 scoops rather. Let's see what they tell us in the first statement. In the first statement, they tell us that 60% got 2 scoops. Well, simply knowing that the 60% of people at the party got 2 scoops is not going to enable us to figure out how many people there were at the party. That information is not worthless. It might come in quite handy later on, down the road, if it turns out that the second statement, listen carefully, if it turns out that the second statement by itself is also not sufficient, then this statement once we put it together with the second statement, might come in quite handy. It is not worthless, but it is not sufficient. A, D, B, C, E. Because of the fact that we just established that the first statement by itself is not sufficient, we know now that the answer cannot be A or D. It would have to be either B, C, or E. Let's look at the second statement. The second statement tells us that a total of 120 scoops were served. Total of 120 scoops were served. Do you suppose we can figure out the number of people that were present at the party simply by knowing that 120 scoops were served? The answer, of course, is no, because some of them were given 1 scoop and some of them were given 2 scoops. We do not know. We do not know. How can we figure out the number of people? Obviously, maybe there was only 1 person with 2 scoops and 119 got 1 scoop, or vice versa. Who knows? What the hell? This does not tell us anything. Actually, 1 person could not possibly have gotten 1 scoop. I misspoke. Perhaps there are 2 people who got 1 scoop. I'm making too much fuss. It's not enough. It's not enough. Let's put them together, shall we? Let's put them together and see if it gets us anywhere. If we put them together, do you suppose we're going to get anywhere if we get them together? The answer is yes. The answer is yes, we will get somewhere, because what we're looking at here are 2 equations. This is one equation, this is another equation. Putting them together will emerge. If we put the information from the 2 statements together in one equation, we'll see something very useful. Let's take a look at it here. When we put them together, 1 and 2. Now when you put them together, you just have to be able to know how to put them together. You don't actually have to take your time to actually solve the equations, you understand? You just have to know, you just have to be able to tell that it is possible to put together an equation which will give us the number of people, and that's all. You just have to be able to tell that we do have sufficient information. Well, we know that 60% got 2 scoops. So we're going to call the number of people, how many people? We're going to call it N. N for the number of people. And 60% of them got 2 scoops. 60% of N got 2 scoops. You see, N is the total number of people. And we are told that 60% of them got 2 scoops. So this is times 2. This is the number of scoops. This is the number of scoops that were received by 60% of people. The remaining 40% of the people got only 1 scoop. And of course, this number here, the number of scoops that were served to people who got only 1 scoop, and the number of scoops that were served to people who got 2 scoop, of course, the total number of scoop we are told is 120. That's it. It's a very simple linear equation. Of course, we can solve for N. Putting the 2 statements together does the job quite nicely. The answer is C. The answer is C. Now what we're about to do actually is a sheer waste of time. This is not something we will do in the real exam. We're going to actually take a couple of seconds for the learning purposes to actually solve it. Just do it together. It doesn't take too long. 2 times 0.6 is going to be 1.2. So 1.2n plus 0.4n equals 120, which is same as 1.6n equals 120. And where can we continue? I need the room. Let's continue on the top. From here, 1.6n equals 120, which is same as n equals 120. 12, I'm going to write this. Actually, that does not get us anywhere, does it? I don't know why I did that. No, we'll see. Let's continue. I could have left it the way it was, which is 120 times 1.6, which is same as 1200 over 16. N equals 1200. I'm going to break it up. I'm going to break it up, and we'll see in a while I want to break it up. Let's divide top and bottom by 4. If you divide top and bottom by 4, this becomes 3 and this becomes 4. I wanted to break it up into 12 times 100 because I know how many 4s are in 100. 100 has 25 4s. So there you go, 3 times 5, 3 times 25. There must have been 75 people present at the party. But that, as I said before, was a waste of time. Let's do the next one, shall we? Number 62, the very last one on the page. Very last one. In the very last question that we are about to do, number 62, it's just a matter of paying close attention to all the variables, all the different things that I mentioned there. Here's what they're telling us. we're going to use P to represent the regular price. We're going to use P prime to represent the discount price. We're going to use P subscript M to represent regular price at store M. At store M. We're going to use P subscript L to represent regular price at store L. We have two stores, L and M. The question is discount price at store M, is the discount price at store M less than the discount price at store L? And using our symbols that we just put together, discount price at store M, discount price is represented by P prime subscript M. P prime subscript M, is this less than P prime subscript L? This is what we're looking for. This is the question. Do you understand? Now let's see what they give us. Before I erase the top part, just give me a second to take a sip. I need the room obviously, so I need to erase the top part. You already got it obviously. The first statement tells us that the discount price at store L is 90% of the regular price. The discount price at store M is 90% of the regular price. But that's not how they phrase it in the question. In the question itself it says at store L the discount price is 10% less than the regular price. If the discount price is 10% less than the regular price, then what they're telling us is that the discount price is 90% of the regular price, which is what we have here. They also go on to tell us that at store M, the discount price is 15% less than the regular price. Well, if it is 15% less than the regular price at store M, then the discount price must have been 85% of the regular price. Let's put that here. P prime M is equal to 0.85 times P prime PM. The question is that enough actually? Is that enough to answer the question that we are looking for? Is the discount price at one store less than the other? It doesn't matter what order it is. The question simply we have to ask ourselves is this enough for us to be able to tell if the discount price at one store is less than the discounted price at the other store? The answer of course is no. Simply knowing that one store is offering a certain percentage of discount from its regular price and another store is offering other certain different percentage of discount at their store does not enable us to ascertain if the discounted price at the first store is either greater or less than the discounted price at the second store. It's not going to do that. The first statement by itself is no good. The first statement by itself is not sufficient. A, D, B, C, E. Because we just found out that the first statement by itself is not sufficient, we know now that the answer cannot be A or D. It would have to be B, C, or E. Let's look at the second statement. The second statement tells us that the discounted price, I'm not going to call it discounted price. I think the proper English name is demands that I say discount price, not discounted price. The discount price at store L, we are told, is $5 less than its regular price. It's $5 less than the regular price. They further go on to tell us, I need the room. They further go on to tell us that the discount price at store M is $6 less than a regular price. It says at store L, the discount price is $5 less than the regular price, which is what we're showing here. At store L, the discount price is $5 less than the regular price. Whatever the regular price is, you subtract 5 from it, and that's your discount price. And at store M, we are told that the discount price is $6 less than the regular price. The question is that information enough for us to be able to know if the discount price at one store is less than the discount price at the other store? If I simply came up to you and I told you that at one store, they're selling it for $5 less than their regular price, and at another store they're selling it for $6 less than their regular price, will you be able to tell me what the discount price is at the two store? The answer to that question, of course, is bloody hell no. Do you understand? It's not enough. It's not enough. I erased it. Where can we put it here? A, D, B, C, E. First we found out that the first statement by itself was not enough, which meant that the answer could not have been A or D. Now we figured out that the second statement by itself is also not sufficient. Answer cannot be B. Let's put them together, shall we? When we put them together, this is where you have to stop and think before you put time into it, before you invest time into it, before you invest effort into it. All we are trying to see is the discount price at one store less than the other store? I'm going to erase this part now, we need the room. The answer, of course, if you put them together, that should be quite obvious here, that it is possible for us to be able to figure out the discount price at each store, because now we know that $5 represents 10% of the price, because the discount was 10% and that's $5. So $5 represents 10% of the discount, 10% of the price at store M, or rather store L. Similarly, here the $6 represents the 15% discount of the regular price of M. Once we figure out the regular price, we can figure out the discount price. Discount price is 90% and 85%. And once we figure out the discount price, we can tell which one is bigger. That's all. Putting them together does the job nicely. The answer is C. The answer is C. That's it. As far as the exam is concerned, we are done. We're not going to waste our time anymore. What we're about to do actually would be a sheer waste of time in the real exam. We're going to actually finish it off just for learning purposes. Do you understand? Not something you will do in the real exam. This part is very straightforward. So the regular price must have been $50. If the regular price is $50, then discount price, of course, is 90% of it, which is $45. Similarly here, the regular price is 6 divided by 0.15, which is same as 600 divided by 15. 600 divided by 15. 60 has 4 15s and a 0, which means the regular price was $40. The regular price was $40. If the regular price was $40, we are told that the discount was $6. That tells us the discount prices must have been 40 minus 6, which is $34. Voila. Now we can answer the question, is the discount price at one price less than the other? The answer is either yes or no. We can give a definitive answer. The answer is yes. The discount price at one store is less than the other. I'll see you tomorrow, okay? We're done with this column. I'm not going to start the next column right now. I'll see you tomorrow, okay? Bye now.